Hi, my name is Ella Irwin, and for my tutorial video, I'm going to be teaching how to do polynomial functions and end behavior. The first thing with polynomial functions is learning to identify key parts of the polynomial function. When you're being asked for the degree, you were looking for the highest exponent or the greatest exponent there is. So for example, this one, it would be 4. Make sure you aren't adding exponents. For example, you aren't adding the 4, 2, and 1. That's a common mistake that a lot of people make. So for the degree, it would just be the highest exponent, which is 4. Leading coefficient, you are looking for this number, the first number, in standard form. We know it's in standard form because the exponents are ordered from greatest to least. So for this, leading coefficient would be 5. The y-intercept, you are looking for the last number that does not have a variable attached. So for this example, it would be 2. But remember, we are keeping this subtraction sign with it, so it would be -2, and there is no variable attached to it. So this is how we know it would be our y-intercept. When we're writing our y-intercept, we're going to write it as a point, so it would be parentheses 0, comma, -2, parentheses. We're going to do the exact same thing for the next example. Again, we're looking for the degree. We just look for the largest exponent that it's raised to. So this would be a 3. And the leading coefficient for this one is tricky because although it's not explicitly written, there is technically a 1 there. So the leading coefficient is 1. For the y-intercept, again, we're looking for the last number that does not have an attached variable. So in this example, it would be 3. We write our y-intercept as a point, so it would be comma, 0, 3, comma. When you start being asked for end behavior, a good chart to use is this one. It tells you with what kind of exponent, what kind of end behavior you will get. So for example, if you have an equation like y equals x to the third, this would be considered an odd positive. It's odd because 3 is an odd number, and it's positive because there is no negative sign written up there. In arrow notation, this would be a down arrow and an up arrow, which would mean that as x reaches -infinity or gets smaller and smaller and smaller, y also goes to -infinity or gets smaller. And then it also means that when x gets bigger and bigger, y is getting greater with it. If you have an equation like y equals -x to the third, we'd classify this as an odd negative because the 3 again is odd, and there's a negative sign written outside. In arrow notation, this would be an up arrow and a down arrow. This means that as x gets smaller and smaller, y is getting greater and greater. It also means that when x is getting greater and greater, y is getting smaller. Next, if you were given an even exponent, for example, y equals x squared, we know this is an even positive because the 2 is an even number and there is no negative sign written outside. The arrow notation would be up, up, which means that as x is getting smaller and smaller, y is getting bigger and bigger, and as x is getting bigger and bigger, y is getting bigger as well. The final example would be y equals -x squared, which would be classified as an even negative. This would have the arrow notation of down, down. This is when x is getting smaller and smaller, y is getting smaller and smaller, and as x is getting bigger and bigger, y is getting bigger. We're going to use that chart to help us with the next couple of problems. So for this one, even though there is not a number written that does not have a variable attached for it, we still would write our y-intercept, which would be 0, 0. It's important you don't do 0, -5, just because this -5 still has an attached variable to it. For the end behavior, again, we're looking for our degree that it's written to, which would be 5. Again, we make sure we don't add the degree or the exponents that it's raised to. This would be a negative odd because 5 is an odd number and there is a negative sign written outside of it. in arrow notation, this would be an up arrow and a down arrow. In infinity notation, this would look like as x is approaching negative infinity, or getting smaller and smaller and smaller, y is approaching positive infinity, or getting greater and greater and greater. This would also mean as x is getting towards positive infinity, y would be getting towards negative infinity. For another example of this, again, we'd first find our y-intercept, which would be a 3. Because there's no attached variable to this, it would just be 0, 3. End behavior, we're going to look at our exponent. So this would be a 2, and there's no negative sign, which means this is a positive even. Arrow notation, this would be up, up. If you're going to write this in infinity notation, it would be as x is reaching negative infinity, y would be reaching positive infinity. Again, as x would be reaching positive infinity, y would also be going towards positive infinity. When we're given an equation like this, the first thing to recognize is that they're written with parentheses, whereas opposed with this one, each one is separated by a plus sign or sometimes a minus sign. In these situations, this is when we add our degrees. So with an equation like this, you first have to know that even though it's not written there, there are technically ones here. So this is 1 plus 1, which is 2. And we notice there's a negative sign here, which would mean it would have a degree of -2. This end behavior written in arrow notation, it would be an even negative, so it would be 2 down arrows. Another thing you're commonly asked for is zeros, and this you're just going to take each of these binomials and set them equal to 0. So for this, we would just take x plus 2 equals 0 and subtract the 2 from both sides. So x equals -2 would be one of the answers. X minus 5 equals 0. Again, I'm just taking this binomial and setting it equal to 0. Then we would add 5 to both of the sides. Zeros are showing us where our two x-intercepts are, so they also help us when graphing. Our last example of this is another one where it is not separated by addition or subtraction signs. So this would be another one where we are adding the exponents. Again, remember that even though it's not written there, these still all have 1. That's a really easy mistake. So you would add the 1, and the 1, which would be 3. It's not a negative because there's no negative sign written outside. The end behavior for an odd, I know it's odd because 3 is an odd number. An odd positive would be down, up in arrow notation. For zeros or finding the roots, we just take all of these and set them equal to 0. Sorry, that's a negative sign. And x plus 1 equals 0. So for this one, we would add the 5 to both sides. So one of them would be x equals 5. For this, we're going to subtract the 2 from both sides, and x would equal -2. This, we're going to subtract the 1, and x would equal -1. So these are each our 3 zeros, or the 3 times that the line will cross the x-intercept. That's all. Thank you very much.